Hey friends, welcome back to the channel, and in this video I'm going to explain you about scale.product-attention. So why I'm making a video about scale.product-attention? So basically I want to learn about the transformer architecture and want to build a mini model based upon this architecture. So since ChatGPT and DeepSeek and all, Gemini and all was in the picture and we are using it in day-to-day life, I was always curious that how this product works behind the scene. So I thought, why not just learn it and create a mini model out of it from this and understand it. So this is here I am, and I'm creating a small model in future, maybe in future, but I decided that I'll go through a 4 step. A first step is listing out all the terminology and terms that has been used in the transformer. Second step is learn about those terminology and understand them and understand all the process. If there is a term or the process, learn about all those things. Third is like build the model uh, and learn the process of building the model. And fourth is hopefully like actually building the model and training the model and using it in the real life. So that's how I'll go 4 step process. So first step was the listing of the terms. So I created a one Notion document and I listed out all those terms. In some videos I'll show it to you guys, but in this video I am starting with the first term, which is very core of the transformer architecture, is scale.product-attention. So let's dive in this video and learn about it. So what is scale.product-attention? And then before that, why we need that? What answer it gives? So basically it gives answer to a particular question, and which is important question. How much attention should model pay to all of the token while processing a particular token? And this has been done through calculating this matrix, which is called attention matrix. Now coming to what is scale.product-attention, and you can see in this diagram there are various component of it. As an input we are passing q, query, key, k keys, and v value. So all three are the vectors. Okay, and then there are various components like matmul, which is nothing but the dot product, scaling, masking, softmax, and again the matmul, and finally we get the final attention score. Attention of q, k, and v is equal to dot product of query with transpose of keys divided by under root of dk, which is square root of dk, and we are calculating the softmax and doing the dot product with value vector. This formula is giving us that attention score, final attention score matrix, which contains the contextual data. So first thing first, how we get q, k, and v. So usually we give the input text, and there are some processing happens, and like input embedding and all, and there are multiplication also happens, and finally we get q, k, and v. In future video I will explain you about the what is the process goes behind the scene to calculate the q, k, and v vectors from the input vectors. What is q dot kt? So it's a dot product of query vector with transpose of key vectors. it gives the similarity between query and key vectors. Higher the values, more similar they are. Next is scaling. Why we need scaling? Scaling is basically when we calculate the dot product of query with key vectors, sometimes values are very large uh, due to the dimensions. So sometimes as we increase the dimensions, key values dimensions, key vectors dimensions, value becomes very large, and when we do softmax, it gives some value to some value becomes very high, some value becomes very low, and finally what it does is like it gives more attention to some token and less attention to rest of the other tokens. So in order to balance out, we do scaling. And how we do it? We do it by multiplying by 1 divided by under root of dk. Dk is nothing but dimensions of keys vectors. Next step is masking. What is masking? A masking is nothing but a way to make model to prevent attending some certain position in the input. So basically we mask some values and we say model that do not take consideration of these positions. Masking are two types. One is padding mask, which is basically we mask all the padding tokens, and in second masking is look at mask. In this masking, what we say that do not look at the future tokens. So these are the two types of masking. By the way, this step is totally optional. Next step is doing the softmax. What softmax does? It takes the attention score matrix and give the probability. So there is some process that happens in the softmax. The process is very simple. It takes exponent of all values, take the sum of all values, take the sum of all of exponent of the values, and divide by each and every exponent of values. It gives the softmax, and it's a probability. It gives the probability. Now the output of this softmax is multiplied with value vector, which is basically the dot product of output of the softmax with the value vector, and this things gives us the final attention score matrix. So I hope you might have understood this. Now let's dive into the code and see that how can we calculate the same things using Python coding. Now we know that what scale dot product attention is. Let's calculate the same with the code. So as you can see that I'm using a Jupyter Notebook. You can also try it. So see, here we are using NumPy for calculating it. All the process and all, we will be using NumPy basically. And first thing first, we are assuming query, key, and values vector, query vector, key vectors, and value vectors. And dk is basically dimensions, which is 3. This is all assumptions actually. Next, we have defined one method, one function, which is skill dot product attention, and that function takes q, k, and v, and mask also. And then function does step-by-step calculation. First 0 step is like calculating the dimension, which is we are doing with shape method of particular vector, that vector. This array will have some shape method, so we are doing it using this, and it gives the value 3. And next is dot product of query vector with transpose of key. So k dot t gives us the transpose of key vectors, and this is the query vector, and then at sign is basically doing the dot product. We are like assigning these values to scores. And next step is to scaling. So we are scaling by dividing scores with square root of dk. We are using numpy square root method of numpy, and it is stored in scaled score. Next step, if there is a mask, if it is provided, then calculate the score, take into consideration also mask value. So this is how we take into the consideration, you can see. And next is like after scaled score, we will calculate the softmax, and the result will be stored in attention weight. And finally, we are doing the dot product of attention weight with the value vector that gives us the output, and in the end we are returning that output. So this is how we calculate the scale dot product attention using numpy. And this softmax function is defined here. It takes basically row wise softmax for 2D array. So basically takes the exponent of whatever the value is given provided, and then it calculate, like it divide the sum of all values with that particular value. It gives us the soft mask values. Now let's calculate the, let's define some mask also. This is how we calculate the soft max, np.rel, which also takes the np.1s 3 cross 3. This is the lower triangular mask, okay, that we are calculating. We are basically calculating this, and it is also a casual mask, and another name is lookout mask, okay. Finally, let's calculate the output, which is context vector, by using scale.product_attention method. So here we are passing q, k, and v, which is the actual value. Here we have defined q, k, and v, and this is the output. And if we second one, we are passing the mask value also. So this is how we pass it, mask equal to mask, and this output will be the width mask. And you can see I have already ran this. I will run it again, and you can see this is how the context vector, which is the final result, is being produced, okay. And this is the attention output with masking, the context vector with masking. That was scale.product attention. Thank you friends for watching this video. I will see you in the next one.